So this is the first in a series of 3 webinars on One Detect to Win. And one of the things that we as defenders need to take heart in is that while the attackers only need one way into our network, they only need to get caught one way. And so what we're going to do over these next 3 webcasts is give you dozens and dozens of detection techniques at the network, at the operating system, and at the application layer, so that you can start turning the tables on the adversaries, so that you can start winning. Because quite frankly, when you look at the scoreboard, if you look at how often there's breaches and attacks, it's quite disheartening. And so what we're hoping with this series of webcasts is that we can help you understand how you can learn your network better and make life tough for the bad guys. Today, we're going to focus on just the network layer. So that's what we're going to be covering, and we're just going to go ahead and dig into that right now. But before we do that, I wanted to chat briefly about the Blue Team Summit and trainings that are coming up. This April, in the 23rd through the 30th in Louisville, Kentucky, we're going to have a 2-day summit on all things Blue Team. And then afterwards, we have a week of trainings. And here's the different classes that are available. I wanted to give you a little bit of info about myself and my co-presenter Josh here. My name is Mick Douglas, and I'm an instructor for SANS. And as you can see, I've got quite a few different teaches coming up over the next couple months. Most of them will be Security 504, incident techniques, hacker techniques, and incident response. But we're also moving me into Security 555. And if you like the stuff that's we're going to be covering today, there's a good chance that one of these classes will be interesting to you. You can also follow me on Twitter at BetterSafetyNet.
Hey guys, I'm Josh Johnson. I don't have any upcoming teaches planned at this point, but I am planning a few different conference talks. So follow me on Twitter at jcjohnson34 for those. And when Mick and I were working on this webcast, we had quite a few crazy coding ideas on projects we could do to help better implement some of the techniques we'll talk about. So check out my GitHub here, and we'll keep posting those as they come available.
So one thing I want to tell you about is we've just got too much content today. For those of you who are familiar with SANS, you'll understand that it's like drinking from a fire hose. Hold on a second, having a technical glitch. It's like drinking from a fire hose. Hopefully you guys can see my screen now. And today we've just loaded this for bear. We've got tons and tons of things. And so we're just going to try to rip through as many things as fast as we can. And some of you probably are thinking, how fast are you going to be going? Well, quite frankly, we're going to be going crazy fast. We're going to be going ludicrous speed. If you've not seen Spaceballs, you need to go check it out. So as was mentioned, this talk is being recorded and is freely available. It will be available on the SANS site, but also I will be hosting this on my own website, infosecinnovations.com. I'll have some bonus material, and you'll also be able to see the notes section of these slides should you want additional information.
All right, so let's talk about how we detect bad guys on our networks. One of the biggest problems I see with SIEM deployments when it comes to network-based detection is that it's just a ton of volume that we need to ingest. And so I'll see these shiny new SIEM deployments struggling immediately once we start pointing certain log sources like firewalls and NetFlow at them. And if you think about it, just a few of these log sources can actually generate tens of thousands of events per second that you're ingesting and analyzing. So it becomes important when you're sizing your SIEM to make sure that you're sizing appropriately for the volume you're going to receive, and then also the detections that you want to put in place. So keep in mind as we go through these different detections today, what kind of hit that will take on your SIEM, and make sure that you're designing ahead of time to handle that hit.
Now, one thing that you need to understand is that SIEMs and the various components that comprise them, things like intrusion detections and log aggregators, don't fail gracefully. It is up to you to measure the back pressure to see if there's a problem occurring. because what will happen is you will create a back pressure or a queue of logs, and then it's really up to the system to see how it behaves. Sometimes you'll be in really rough spots where you're not able to correlate information correctly. I've seen cases where critical logs were dropped and lost forever. And I've also seen cases of where a SIM, which was a really nice, name brand one, where they overloaded it. And what happened was it took 90 minutes for each query to execute. And I was on a purple team engagement where the attackers and the defenders were sitting together. The attackers would send an attack, and then the defense would see if we were able to detect. And what was unfortunate is each attack took 90 minutes of analysis from the blue team to figure out what was going on. By the time we hit lunch on day one of a week-long engagement, we had over 2 weeks of queries to do on that SIM environment. So one of the biggest takeaways that you can have is aggressively monitor for back pressure in your environments. Another problem that you need to be very mindful of is retention. All too often, organizations have this ultra-conservative approach of where they retain everything on the off chance that it might be needed at some point in the future. And quite frankly, that's a really bad way of doing things. We'll talk about this toward the end of the lecture today on how data has basically a half-life and it's pretty short. So what you need to do is find a length of retention that works for you, bearing in mind that you may have regulatory frameworks or contractual obligations that means that you need to keep the logs for a certain length of time. But otherwise, you might be able to get away with having fewer logs, which actually makes you have a better tempo and frees up the cycles on these systems so that you can do some of the things we're going to start talking about.
So as Mick mentioned, there's not a single detect to rule them all. There's just too many ingress and egress techniques at this point for one blanket detection method to work against everything. If we had to choose and just pick a single tool, though, we'd pick Security Onion. And a lot of the different screenshots and techniques you'll see in this webcast are directly taken from Security Onion data. And with the newer versions of Security Onion baking in Elastic instead of ELSA, they're actually starting to utilize some of the enrichment and augmentation techniques that we'll discuss in future slides. So it's like by installing Security Onion, you get an NSM suite and a SIM built into one platform at this point.
One other thing that is really important is that there's no mistakes when it comes to doing this work. Just happy accidents, as Bob Ross says. There's no science to what we're talking about. There really isn't. This is still a relatively new field, and it's more art than science. And oftentimes you will find that there's a query that you run and you get unexpected results, or you place a sensor at one point in the network and you start seeing traffic flows that you don't expect. You know what? That's a good thing. In fact, it's an amazing thing because you're on your way to understanding your network, your environment in a way that you didn't understand prior to that happy accident taking place. The reason I mention this, and I cannot stress this enough, the reason you need to get into this mindset is you need to experiment. And when things go wrong, and they will, you need to learn how to use those happy accidents to your advantage, because quite frankly, that's where the real breakthroughs will happen in your career.
And along those lines, I often see a problem where organizations will install a new SIM and they'll point their log sources at it, and then they'll sit back and just wait for that SIM to start alerting them. And in my opinion, that's the wrong approach. Even though some of these commercial SIMs have excellent rules built in, they're not always one-size-fits-all rules. So instead of that, I would encourage you to start analyzing the data yourself. Use the detection techniques that we talk about here and in SEC555 and any other resources you have to start asking your SIM questions. And when you get answers to those questions, analyze the data, refine your questions, and keep iterating through that process. And once you have a question that you like and an answer that can be in an automated fashion analyzed, start to use the automation capabilities of the SIM to automate those processes. And it's funny, I've always heard of the security guys who can go into the data center and put their fingers up in the air and the wind shifts directions and all of a sudden they know something's wrong. And I thought those guys were kind of like unicorns. And then I went to a SANS conference and I met Mike Poore. And when I met Mike, he was looking at a TCP dump capture in real time, and he was just annotating it verbally, what he saw going on. And then he goes, wait, hold on a second. Scroll back to that. And we went back up and he, on the fly, looking at this TCP dump capture, noticed something that we dug into and found was malicious on the network. So my point to all of this is the better you know yourself and the better you know your own data, the more quickly anomalies will start to pop out to you. You can use that to your advantage, as Mick was talking about. Get creative and keep learning your own data and use like the baseline capabilities of your SIEM to help with that process. Now, I'll admit, when you get started with monitoring big networks, it can seem a little overwhelming. And I often see folks who want to focus on the sexy offensive techniques when in their monitoring, instead of maybe taking a step back and starting with the fundamentals. I'll see things like, hey, I want to detect PowerShell Empire calling home to its command and control server. And while that's a good detection to have, and I certainly support that, it isn't always the case when folks know exactly what's happening with their crown jewels. So my suggestion is always to focus on your most sensitive data, whether that's your applications, your databases, whatever, and build a dashboard within your SIEM on that data. And learn to love that dashboard. Look at it day in and day out. And get so familiar with that data that you could hear a pin drop in that environment. And then at that point, once you're that familiar with your sensitive data, then start working your way out to the perimeter.
And now that you've mentioned perimeter, it's time for me to go on a little bit of a rant. All too many organizations have focused entirely on the perimeter. They defend the perimeter because that's where the attackers are. And you know what? That's not bad per se, but the problem is that's coming from a playbook that, quite frankly, is years, maybe even decades out of date. As a result, we have hard, crunchy outer shell networks with soft, gooey centers. And we've got to stop that. Part of that is knowing where your crown jewels are. Many organizations have network diagrams. But if your organization can show me where the data flows over the network, I can start talking about, are the sensors in the right place? Is the network segmented correctly? Do you have the proper controls to protect the data that needs protecting? Not many people have that, and we need to start flipping things on their head. Otherwise, it's just going to be more of the same. So I know this sounds weird, and this might be the most controversial slide in this entire presentation, but just for a bit, forget about the perimeter. Focus on the data.
Now, when we start to look at our filtering devices that are in line, like our firewalls and our IDS, they don't have the luxury of leveraging too many external data sources in real time, like whois lookups, for example. The end user experience would be just atrocious if they tried to do these things in real time and filter with this data. Our SIEM, on the other hand, has all day to update that data with this enrichment and augmentation as it's ingesting it or as it's analyzing it. So a lot of the techniques we'll talk about below leverage things like whois lookups, forward and reverse DNS lookups, and frequency analysis. So keep in mind, as you build out your SIEM, you would want these types of enrichment and this type of augmentation to better utilize these detection techniques we'll talk about. Some of the best detection techniques I've found are really, really simple. For example, top and bottom talkers per protocol. All you're doing is summarizing and sorting the data you already have. This doesn't involve any sort of augmentation or enrichment. It's just looking at the data that you have. And some malware is pretty stealthy, but sometimes it'll go a little haywire and get really chatty. And all of a sudden, those top and bottom talkers per protocol, the infected machines bubble themselves up and just hand them to you on a silver platter. And as Mick and I were talking, when you become more comfortable with your own data, you'll get comfortable with these reports. And it'll be a quick thing that you can just take a look at each day, and you'll notice what's good and what's bad right off the top of your head. And then you can start building some automation behind that to start alerting you on things. I promise not to let Mick rant too much on this slide, but Mick, do you have any comments?
Well, one thing you also want to take a look at is not just top and bottom talkers per protocol, but maybe who's increased or decreased the most in the last 24 hours. So if all of a sudden you see like a ramp up that's out of the ordinary, that could be of interest. So again, it's all about getting creative and just doing some interesting and meaningful research on your own network. Don't let the vendors buy you into the hype of you need to use machine learning or AI, this or that. So far, everything that we've been talking about is actually basic statistical math, really simple things, and it's not computationally expensive. And every single SIEM, even the open source ones out there, support this out of the box. So do you want to advance on to the DNS detects?
Sounds good.
All right.
So let's start talking about some protocol-specific detection techniques. And I want to start with DNS because I'm a geek and that's my favorite protocol. And for all too long, I think it's been ignored as a possibility for doing detection. I think it's starting to gain some traction now, but there's things like new domain access that we can leverage just based on our DNS logs. And in this case, what we've done is we've taken 90 days of aggregate DNS data, and then we're comparing our DNS requests from the last 24 hours to that data set. So if in the last 24 hours, we've made a request to a new domain, that's maybe something we should look at. You know, we're creatures of habit. We like to do the same things over and over. And when I drink my coffee in the morning, I browse Reddit. The enterprises aren't much different depending on your industry. So this is a quick and easy one, just a report you can run to find new domains being accessed. Another really cool technique is frequency analysis. And Mark Baggett wrote this great script that takes in a string or a dictionary and then determines common character combinations and then takes your input and gives you a frequency score based on how random that input is. So we can do things like measure our DNS requests and look at the query that's being made and pass it into this function. And what it does is it returns a value, and the lower the number that's returned, the higher the frequency, the higher the randomness of the domain. So if we look at this domain here that's being accessed, to the naked eye, that is very, very obvious that there's a problem. But if you're dealing with millions of DNS requests, how do you bubble this up to the top of the list? And I think frequency analysis is the answer to that problem. This one would jump right to the top of the list and be investigated right away. Baby domains is another good one. Generally, we like to communicate with domains that are well established, not domains that have been recently created. So if we enrich our DNS data with who is information, we can pull things back like creation date for a specific domain. So if we're looking at our Bro DNS logs and we see communication to a domain that was created just 2 hours ago, there might be a problem there. Even a few days ago, there's probably something weird going on there. So let's switch gears a little bit to HTTP. One of my favorite techniques to bypass URL filtering systems is this one right here. And what we're doing is we're using curl to make a request to sec555.com. And we're setting the host header in the request to www.google.com. Now, if you run this in your environment and your proxy is just scraping out that header field and making its decision based on that, it'll probably show logs that look like you're just browsing to Google. Now, if we marry up our DNS data with our HTTP data, we can trace this one out and figure out something's going wrong. In the first request here, you see a query for sec555.com, and then you see an answer with the 198 address. Immediately after that, you see a connection to that 198 address, and the virtual host field in that request is for www.google.com. If we marry up those two indicators, we can tell something is clearly going on there, and we can then pivot to the packet capture to figure out what's actually happening.
Another thing that you need to be mindful of is that attackers are creative too, and they're going to be doing weird things like response splitting, where they add carriage return and line feed into the HTTP protocol. And in this case, what's happening is we're making a request, or the attacker's making a request, which will also add a relatively new header called cross-site scripting protection. Normally, this value is set to 1. That's how browsers will, from time to time, if you're doing web research like I do, you'll see, you may see a warning, or depending on how your browser is even configured, you may get a pop-up that says, hey, this page has a malicious script. And that's handled by the cross-site scripting protection value in the browser. And I've only seen this a couple times in the wild, but what surprised me was that the artifacts that this rather sophisticated attack uses does generate some really easy to spot telltale signs. You would never ever expect somebody to be doing this sort of post, and yet, or a get like this, and yet you can see that. So look for it.
Another useful technique is frequency scores within HTTP requests. So we talked about this with DNS, but frequency analysis is useful for all kinds of things like HTTP host fields, certificate names, DNS names. And in this case, we see a client that's using a domain generation algorithm to create a random domain name. There's no DNS request associated with this. It's just calling directly out to the internet via HTTP and leveraging this in its virtual host field. So if we're only looking at DNS, we'll miss that. But if we're also looking at host frequency analysis on the host header, we can catch this with the same exact technique we use in DNS. Now, if you think about how normal HTTP traffic should work, if I open my browser and I type in google.com, my machine makes a DNS request for that name. And then when I browse to the site, it makes an HTTP request. And inside the request, the host header is set to the domain I'm asking for. A naked IP, on the other hand, is when the host header is set directly to an IP address. There's no domain name used there.
Does anybody ever do that?
Absolutely, I know I do.
You're fibbing.
So yeah, in reality, this does happen occasionally. Some security tools will leverage naked IPs on their outbound requests, so you will see false positives. But with a nice whitelist, you can ignore that traffic and then focus in on anything that is not known to be good naked IP traffic. So really, all we're doing is scraping that host header field and looking for an IP value in that field. So we were talking about naked IPs and how could we detect them in non-HTTP protocols. We came up with this little Python script that basically takes your bro/con logs and it looks at all outbound connections and scrapes out the destination IPs from those connections. And then it aggregates all of the answers in the DNS logs that we've captured. And then it compares the two lists and it looks to see if there's any outbound connection with no DNS request associated with that IP address, it alerts it. And full disclosure, in an enterprise environment, this one does generate quite a few false positives. But what you can do, day after day, those false positives were the exact same in my case. So what you can do is build a whitelist in this case as well, and then just start ignoring the stuff you see day after day and just look for the new naked IP access. So let's move on to HTTPS traffic. It's a common problem for organizations to want to get into the middle of that traffic. And if you can get into the middle of that traffic by decrypting the SSL connection, you gain all of the same visibility techniques you can use on clear text HTTP traffic. The problem is I see this done incorrectly very many times where the proxy, for example, might make a connection out to an end web server and it's using a downgraded protocol from what the client would actually use. And I also see cases where the proxy won't actually validate the external SSL certificate. So this is a hugely valuable technique, and please use it if you can. but make sure to do it correctly if you're going to use this technique. Now, if we do decrypt SSL traffic, we can do things like detect domain fronting. And what domain fronting is when an attacker uses a CDN or some sort of reflector service to make a request to a seemingly benign site, but then when it hits the CDN, it gets redirected to an attacker-controlled server. So in this case, if we step through this diagram, the compromised asset makes a request for Amazon.com. The DNS server says, hey, that Amazon.com is at this IP address and this CloudFront address. So the connection then goes from the client to the CDN on the IP address with an SSL connection and a server name field set to Amazon.com. Now, if we're not decrypting this traffic, this is where we go blind. We only see the SSL connection with that server name field in it. So if we are decrypting, we get access into this host header. So let's take a look at the logs and see what that looks like. So if we step through these events, first we have a DNS event where we have a query for Amazon.com, and you see the answers with Amazon, an IP address, a CloudFront address, and so on. And then we see an SSL connection directly to that IP address in the answer. And the server name field is set to Amazon.com. It all looks legit at this point. If we are decrypting, we can also pair up the HTTP request encrypted within that SSL request to inspect the virtual host field. So here we see that there's this virtual host field of a CloudFront address that's not the same as the server name, and it's not the same as what was answered in the DNS request. So we very clearly have something weird going on here that we need to pivot on to packet captures to investigate. So again, we've decrypted this traffic so that we can see this host header here in the request. And when we compare it with these other data points we have, we see a discrepancy. And that is one way to detect domain fronting using SSL decryption.
And what's powerful about this is that this should have a very, very low false positive. So this is a great way to break into an attack that, quite frankly, works way too well when I'm doing penetration tests.
So all hope is not lost if you decide not to decrypt your SSL traffic. If you couldn't tell at this point, Mick and I are huge Bro fanboys, so we're going to keep talking about Bro. But there's certain fields in Bro SSL and Bro X509 that we can use to get some good detection capabilities without actually breaking that encryption. One of those is the validation status field. So when Bro sees an SSL connection, it validates the certificate. And if you start seeing random self-signed certificate usage on your SSL connections, it might be the sign of a man-in-the-middle attack. On the other hand, there was some really interesting research done recently on packet captures with various malware variants in them. And the researcher pumped them through Bro and then looked at the SSL traffic and noticed that certain things like the country code and the organization were actually blank fields within those malware variants SSL certs. And when you compare that with what normal outbound SSL traffic looks like, it's a complete discrepancy. So, you know, just by taking your SSL traffic out to the internet and filtering for missing fields that are commonly existing, you can have a really nice detection there. The notes in this slide should link out to some research that was done on Bro X509 and detecting Metasploit. But what the researchers did was they figured out they wrote a Bro script to figure out the Metasploit certificate generation algorithm. And just by measuring the values in the X509, they were able to detect Metasploit usage without breaking the encryption. Another neat thing you can do with Bro SSL is watch the cipher usage that's going across your network. So not only can you find where weak ciphers are being used, but you can check for if connections start getting downgraded, it might be some sort of man-in-the-middle attack just by leveraging the values in that field.
Now, at this point, you do know that we're hardcore Bro fans. And what I would encourage you is, if this sort of thing interests you, Josh and I would be willing to do an ongoing series of presentations, probably starting with the whole SSL analysis, because there's so much cat and mouse that goes on here with the malware. And quite frankly, you could probably make a career of doing nothing but just doing the SSL and X509 analysis that Bro gives you. And it's amazing. So if it's of interest, let us know and we'll make that happen. At this point, I want to chat with you about what I find one of the weirdest things that attackers do. And I'd like to think that part of the reason this is such a big problem is that defenders don't quite understand or realize how lazy attackers have gotten, or probably have always been. One of the things that I see all the time when I'm doing incident response, or that I replicate when I'm doing a penetration test, is I'll be the attacker system right over here. And instead of going through the normal proxy that's available inside the corporate network, I'll go straight out to the internet. And if the egress, that is the outbound firewall rules, are relatively lax, I'm going to be able to go straight out to the internet, and I'm not going to be detected because I'm not going through this proxy system. And what's a shame is that the next couple slides are actually this whole thing, this whole concept, just with different protocols. And I don't want to beat a dead horse, but it is worth pointing out just how endemic this problem is in our industry. So first of all, let's start with DNS. Josh said that he's a DNS fanboy. I'm a DNS fanboy. If you don't like DNS, you probably got to learn to love it, because from a detection standpoint, it is so powerful. And if you think about it, every single person in your environment should be speaking with your corporate DNS servers, or the DNS servers at your ISP if you don't have your own internal ones. Anybody who's going directly to the internet, well, frankly, that's weird. And at the very best, it's a misconfigured host that has the wrong DNS server entries. But what's more than likely is that it's some attacker doing some sort of DNS tunneling. And there's plenty of good papers in the SANS reading room about how to detect DNS tunneling. You can even detect or test DNS tunneling in your own environment if you'd like, using tools like DNS Cat 2 that was made by Ron Bose, or shameless self-promotion. You could check out PowerCat, which is an implementation of Netcat written entirely in PowerShell that I was the co-author on with Luke Baggett. So that allows you to do DNS tunneling. And you should see people going straight out that aren't going through your DNS server. Yet, on most pen tests, I'm able to do this. And quite frankly, the only things in your environment that should ever be going outbound with DNS are your DNS servers, maybe your DNS admins. Outside of that, something really weird is happening. Take a look and see what's going on. The same is true for web traffic. Most organizations have a web proxy or a web content filtering system of some sort. Make sure that you're monitoring for people who are going around that. And there's a variety of reasons you want to do that. Number one, you want to make sure that you're catching anybody who's trying to circumvent, maybe like downloading inappropriate material or doing, file sharing or BitTorrents. You can detect that with by noticing who's dodging your web proxy. But the other thing is, there are many attackers who will make use of command and control, and it looks like normal HTTP and HTTPS traffic. And the thing that I'm here to tell you is that it is really hard to tell that traffic, the good traffic from the bad, if you're not doing this sort of check, because anyone who's doing web traffic outside of the proxy is immediately suspect. So start looking for this, please, I beg you. I want my job as a pen tester to be harder, not easier. This one gets me super angry, mail traffic. You should never, ever, ever have hosts in your environment that are sending mail outbound to a web or to a mail server that is not one you can control. Now, I understand people are moving to things like Office 365 and Google for like the corporate Gmail. I'm not talking about that. What I'm talking about are attackers and people who are talking SMTP outbound to someone on the internet that you don't know about. And what they're doing is they're bypassing your mail server or your mail transfer authority, MTA. And for goodness sakes, this isn't hard to detect. You should be able to check for this using things like your NetFlow, or you can even check for that at your firewall logs. Look to see where things are going out. You should be detecting this. Yet, most organizations don't. And you know how they find out that they've been hit with this particular attack? They find it out because all of a sudden they can't send email. What happens in this instance is the attacker system maybe isn't an attacker, maybe it's a victim, and they're now part of a spam botnet. And this poor victim machine now is just flooding the internet with all kinds of, spam for genuine replica Rolex watches or whatever. And instead of normal, web traffic being, mail traffic being caught and analyzed, this sort of stuff happens all day long and you get blacklisted. And I'm here to tell you, that's a really rough day when your CEO, your CTO, or your CISO comes to you and says, hey, I'm not able to send email. Help me out about that. Let's also talk about NTP. NTP isn't really truly a proxied protocol. In an ideal world, your machines are going to go to your local time servers or whichever server you're configured to go to. You almost never have people going straight out to the internet to some internet time server. That's weird. You don't want that. A lot of the denial of service attacks, a lot of the distributed denial of service attacks take advantage of the fact that many corporate and government organizations do not filter NTP outbound. And so you can craft, as an attacker, you can craft a malicious NTP request. And because NTP is based on UDP, you can easily spoof the source and they will make a request appear that it's coming from another organization. And your organization will be sending out spoofed packets, and all of a sudden you're part of the problem. You're part of a distributed denial of service attack. And why? Because you weren't looking for some basic things like this. I get that these things are low tech, but you know what? It's an easy detect, and this never should be a problem in the first place. If we as an industry start doing better egress controls, and I'm not even talking like blocking, just detecting, just start detecting on the outbound, and we're going to start doing a better job. The real shame and sorrow of our industry right now is that most attacks and most compromises are detected by third-party organizations. And the reason they're detecting it is this outbound block right here, that X right by the firewall, this isn't taking place. This block never occurs. And what's furthermore is there's no alerts generated. You should be generating an alert any single time any host tries to go around those sorts of services. And quite frankly, there might be more. These are just some quick and easy wins. You probably in your organization have some applications that work in a proxied manner or in a federated manner, and you should be detecting those. Start detecting them, because I'm here to tell you, until we as an industry start getting better at this, it's not going to improve in any way. Let's keep talking about the flows and talk about how you can use things like jump boxes and management boxes as part of your detection routines. Whenever somebody tries to connect directly to a protected server, that's weird. No one should ever be doing that in your environment. And I don't care what protocols they're doing, SSH, RDP, VNC, VPN, however it is that you connect to the protected servers, that should be coming from your centralized management box, your jump host, your RDC server. your SSH jump host. I don't care what you call them in your organization. You should have them. You should use them. And any logins that don't come from this box, well, you got trouble. You need to start investigating, and you need to start investigating quickly, because not only do you have somebody in your environment who's trying to interact with those hosts, they know the host to interact with. They've already got an understanding of your network. So you don't just have an attacker on the wire, you have an attacker on the wire who knows what they're looking for. So you need to jump on this really, really fast. And again, the problem is, by the very fact that they're trying to interact with those hosts, you should see this. You should have a firewall. You should have a router ACL that blocks that direct access. If you're using jump hosts, you need to have something that enforces this. And a simple firewall rule is all it takes. And when this block occurs, you want that alert to be sent. And I know this sounds weird. Normally, a firewall rule block is a relatively low and an innocuous event. In this case, I got bad news. This indicates that this attacker here understands your environment a little bit better than you may want them to. So whenever you see this happening in your environment, it's up to you to jump on it fast. If you don't, it's going to be a real rough day quickly, because chances are they're going to find places where this firewall rule doesn't exist, or they're going to get lucky and they're going to get into a box that you thought you protected appropriately. Maybe there's, asymmetric routing and they find another way in. It's going to be a bad day. This is something that is one of the early stages, one of the earliest detects that you can use when the attackers are going in their post-exploitation phase. So use their reconnaissance against them, because if you don't, it's going to be a body count. In fact, it's already bad. They've got some machine in your environment. I'm just trying to prevent it from being a situation where all hope is lost. Let's take one even more basic than what we've talked about. In a normal world, your internet access to your DMZ networks is inbound. The ultra majority of your connections are coming from the internet to DMZ web servers. They're responding to requests. What you need to be on the lookout for are DMZ servers that are initiating outbound connections. That means this server sent out the SYN. If you look for something just that simple at the firewall, see who the source of the connection is, and if your DMZ firewalls are the source of the connection, you got problems. Usually what this is an indicator of is that the attacker was able to do some sort of an attack where they did something like a remote file include, or maybe they were able to upload a file and do a local file include. Maybe it's a SQL injection attack, maybe it's a command injection attack, I don't know. But the story here is the bad guy has some level of control on this machine, and this machine is phoning home to a system that the bad guy controls. Now, I want to put a big asterisk there. There are going to be some exceptions to this. Your mail servers, your file transfer systems, maybe you've got an update server that's going to reach out and look for updates. But you know what? Just as Josh said earlier, have your whitelists, know what you expect that machine to be interacting with, and you'll be able to have a very, very low false positive rate. And quite frankly, the computational effort here on this one is so negligible. And yet, I can count on one hand the number of organizations I know who are doing this detection. Do yourself a favor and start doing this detection, because otherwise you won't know when the bad guys have started their campaign inside your environment. And that's a scary thing. But it goes beyond that. You don't have to use that technique just at the DMZ. You can use that on what I like to call quote unquote receiver devices. Things like printers, print servers. Those machines receive connections. They don't initiate it, or at least they shouldn't. If you want to understand just how scary printers can be, you should check out a guy named Daryl Hyland, %0x. He's a hell of a good researcher, and he loves using printers as part of his attack platform as a pen tester. And he has this saying that scares the snot out of me. He says, "When was the last time you patched a printer?" And every time he says that at a conference, people kind of nervously laugh, and he goes, "No, really, when was it?" And then everybody kind of looks at their shoes and says, "Yeah, I don't know." And he's like, "That's what I thought." So start looking for these sorts of devices that are sending traffic out into your environment. That is weird and should not be seen ever. You know, other things that are good candidates for this, your cafeteria kiosk that shows the cafeteria menu. That menu should be pushed to that server or that kiosk. That kiosk shouldn't be interacting with the rest of the network. You'll also see similar things with badge access systems. The badge access system should be receiving requests from the badge scanners, not interacting with the rest of your network. So be on the lookout for things like that. But this is the scariest slide of them all. Workstation to workstation traffic. You should never, ever, ever, ever have workstations talking to one another. And yet this is a very common thing that I see all the time. Organizations that allow the workstations to talk to one another have two problems. Number one, they most definitely have shadow IT, where the organization, you're going to have like people sharing files with one another. But the bigger problem is the bad guys are pivoting in your network. They're moving from machine to machine to machine, and you're not seeing it. You need to have host intrusion detection or network flow data that sees the east-west traffic inside that network. Here's some ways that you can detect some of the flow information that I talked about earlier. RITA, it's from Black Hills Information Security. Big fans of Black Hills InfoSec, hey guys. And check this out. RITA, the Real Intelligence Threat Analysis Platform, allows you to do, in the words of John Strand, it eats bro logs and spits out awesome. What you do is you point your bro sensors at RITA, it sends the logs to RITA, RITA does the analysis, does things like frequency calculations, does flow data, and if you don't have Elastic or Elastic type tooling in your environment, it's a great tool to have.
If you are leveraging Elastic in your environment, Flare by Austin Taylor is another tool that just spits out awesome. It will reach in and suck out your flow data out of Elastic and then do the same type of analysis and look for this regular beaconing talking out and then present you with a beautiful report on what it thinks might be beaconing. So the GitHub is linked in the notes here if you want to check that out.
But I don't want you guys to, think of just network devices as information. You can get creative. One of the best things that I've ever seen was I had a client who was using the system logs as quote unquote flow data. There were a couple network zones that they didn't have sensors and they couldn't set up span ports for whatever reason. I don't remember why or how, but what they did is they used the application logs from the servers in that environment to see what network data was coming in and out for those environments. Remember, almost every single application log out there that accepts remote communication will log where that source was. So you should be able to very easily see who's interacting with your remote machines and start asking questions like, why is Bob from accounting interacting with the R&D SharePoint server or file shares?
So switching gears just a little bit, when I think about setting traps for attackers, I always think honeypots. But from a purely network-based detection perspective, we can use quite a few different techniques. And one of those is canary files. And when you're using Bro on your network, when Bro sees a file moving, it hashes that file. So one really simple thing we can do is we can create dummy files or production files, whatever we want to use, and hash those files and then just sit back and watch for those hashes to move across the network. It's just a canary that when we see this thing moving across the network, we know we have trouble because that file should never be moving like it is. And then we can use scripts to automate this entire process. So even if it's production data that you need to hash and then update your Bro scripts to look for, you can use scripts to automate the entire workflow. Another really cool technique is honeyports. And if you haven't heard of Artillery by Dave Kennedy and the Binary Defense guys, please check it out. It is a tool that allows you to generate fake services running on real systems. So you can generate these honeyports where a Windows box is now listening on ports 21 through 23 and accepting connections. And then once it receives a connection on one of those ports, it blacklists the offending host and then issues an alert for us as a blue team. Now, I have seen this wreak havoc on pen testers before, where they'll hit an artillery a box running artillery, get blacklisted, have to pivot somewhere else, hit another host that's running artillery, and so on. And it just frustrates them to no end that they're constantly hitting these honeyports. And meanwhile, as a blue team, we know every box that's getting popped and how the attacker is moving laterally because we can watch where they're hitting these honeyports from. Web bugs are another cool one. A web bug is when you can place a file on a web server that shouldn't normally be accessed. So you embed it in the source of a page somewhere that is fairly easily detectable by a crawler or a scanner or someone just poking around trying to learn more about the application. And then you alert whenever you see that file being accessed. And I've made the mistake of deploying these out on the internet before, and honestly, it's boring. You get hit with every scanner, trips your web bug, and you get an alert that you don't really do much about. But if you're doing this on your internal network, embedding these in your web apps on the inside, you can see potential compromised users poking around, a compromised account masquerading as a user poking around at your web apps, and detect those compromised reconnaissance internally without having to actually put a preventive control in place.
Some other things that you should be thinking about if you want to move more to the active defense side of things are using things like DNS sinkholes. Remember, it's your infrastructure, it's your DNS server, so you control where things point to. And just like this guy's pointing to the obvious hole and saying, hey, well, your problem's right there, why don't you use that to your advantage? Malware in other systems is either going to use naked IPs, which you should be able to detect, as we talked about earlier, or it's going to use DNS. And so if it's using DNS, you can twist that and do a judo flip against that malware or that attacker tool and point it to IPs of your choice. You could put that to a machine that maybe, you know, is a cleaning system. And if you understand the malware well enough, you could actually, and I have seen people do this, you can actually send commands to the malware to clean itself up. So DNS sinkholing, incredibly powerful. Look into it. Other things that you can do are use honeypot zone transfers. So one of the things that attackers love to do when they find a DNS server is attempt to do a zone transfer to see if they can pull the zone information or the entire list of all the IPs and hosts that are in your environment. It's one-stop shopping for the attacker. When the attacker does this against a prepared DNS server, though, what they'll do is they'll get the zone transfer, and it works as they expect it, but instead of having the actual information that they need and want, it's going to be filled with all kinds of IPs and host information that seems interesting to the bad guy, but points them to a tar pit. And tar pits are relatively simple. What they are services that listen on the network and are slow to respond. And just as artillery frustrates bad guys, having been a pen tester and I've gone against a tar-pitted environment, it frustrated me to tears because now I couldn't run tools as simple as nmap without expecting a super long delay, and I knew that the opposition, in this case the blue team, was monitoring and watching that traffic. So it slowed me down, and I knew that it made my attack reconnaissance traffic appear all the more easily from the ready normal traffic. The one tool that I would encourage you to take a look at is an older tool called La Brea, and it's named after the La Brea tar pits that are inside Los Angeles, California. And I'm here to tell you, it's an old tool, but man, it works, and it works really well. Other things that you should be doing is using network services and doing baselines against those, and it is so easy, there's no excuses anymore. One of the things that I love to do is nmap plus ndiff. What you do is you run your nmap scan like so, and is put it in an output format using this -ox to put it in an XML format, and have your known good results, and then once a day run another check and use ndiff to do the different compare, and you'll see in this case we got this new port 4444, the default Metasploit port, up and running. That's something you can jump into, so you can do your analysis on that. Super easy to detect, works well. There's no excuses for not doing that. From time to time, though, and we all have these in our environments, we have those quote-unquote fragile systems where it's scary. Somebody scanned it once and it broke and everything went to, you know, all heck. Well, this is a problem, and I understand it's a real thing. And you know what you do? You passively monitor them, because legacy systems or embedded systems usually have a narrow or a smaller TCP stack than traditional machines. And so analyzing them in a passive manner is easier because their network traffic is significantly more repeatable than a quote-unquote normal host. Let's talk about the decay of data value. I love full PCAP. I love having all the logs. And you know what? If money is no object, I will hold on to them as long as I can. But the sad fact of the matter is money isn't infinite. And so what you have to do is start making choices. And just understand that the value of data decays as time goes on. And so if I can have a PCAP for 48 hours, that's awesome. And then from there, I can start moving more and more to summary data, because quite frankly, I don't need all that data all the way back. Now, one little caveat, make sure you work with your regulators to make sure that you're hitting your regulatory and contractual requirements. Otherwise, you might be setting yourself up for a world of fines. So, we went through a whirlwind of detects. Hopefully, these didn't seem too difficult. And quite frankly, they really aren't. It's just there's a lot of little things to do. But you know what? Our goal here for today was to just put as many arrows into your quiver as possible so that when you face the adversary, you have as many options as possible. Part 2 is coming up on March 2nd, where we're going to be talking about tactical endpoint detection. And before we go, we want to answer a couple questions. Holy cow, there's a lot of them. I think that in the interest of time, I'm going to try to do a couple of these. How do you simplify and ingest, remove your false positives? Well, so the easy answer to that is you start slow. Find a log source that's of interest to you and make sure that you're ingesting that log source appropriately and correctly. Many SIEMs fail because they don't do a good job of parsing the log correctly. Pro tip, if you ever take SANS 555, the teams that parse the logs the best and the quickest are the ones who win the capture the flag. Josh, do you have anything to talk about that on false positives and log ingestion? Because that's a huge one.
No, I totally agree with your points there. I think it's very important to make sure that you don't just point several different log sources at your SIEM and hope for the best. You need to go one by one and make sure those are properly tuned and parsing correctly before you start using any sort of detection logic against that data.
Yeah, and it does sound tedious, but over time you get faster and faster at it. Otherwise, what you're getting is just a slew of data that really isn't actionable, unfortunately. Well, I think we're running low on time, so if you've got other questions or comments, we'll try to respond to them. Shoot us stuff via Twitter, and we'll respond as we can. But we really appreciate everybody who came and attended live, and for those of you who are watching our rebroadcast or a recording, thanks for giving us the time. Take care.
All right, well, thank you so much, Mick and Josh, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.